See the assumptions here. Assumptions made by Westergaard. One thing we must highlight here also, the soil is elastic because it is also elastic theory. The second point we should keep in mind when we are discussing Westergaard's theory, here the load is point load. Again, I will tell you, Westergaard elastic theory also initially it is proposed for point load. And it's very important discussion. The soil can be anisotropic. This is the major difference between, whereas in Bouchner's theory, same assumptions we can take ditto. But whereas in Bouchner's theory, we assumed soil is isotropic. So what we are going to discuss now is very important. Here you see, many times in reality, soil is having, if you see the ground is having different layers. Let me say it is a silt or clay, again silt, again clay. So we have alternate layers of soil. So in reality, many times if you observe the ground may not be homogeneous, or what I say, especially isotropic. You have a silty soil up to certain depth, then followed by clay soil. So here you see different depths are there. But we had a major resistance, major constraint with Bouchner's theory. Bouchner assumed isotropic, soil is isotropic. Whereas if you are having a stratified soil, that means if you are having a stratified soil, if ground consists of stratified soil, you can use Westergaard theory. So you can go for Westergaard theory. Whenever the soil is isotropic, that means whenever your ground consists alternative layers of silt, clay, or some other gravel or sand. So the soil is not isotropic. What I would like to tell you, here it is not pure silt, it is not pure clay. There are alternative layers of silt, clay. That means Z square, I will write it. When I need to see the equation, 1 minus 2 mu, I need to write clearly 2 mu, this is mu, by, again, 1 minus 2 mu by 2 minus 2 mu plus r by Z square whole power 3 by 2. See, it is really a big challenge to remember this equation, but I will help you. No doubt I am going to help you. So here someone can ask me what is mu. Here it is mu. So I will write in Telugu. Sorry to write in Telugu, mu. So the pronunciation may not reach you. That's why I'm writing it is mu. Mu is undoubtedly Poisson's ratio. And Q is point load. There is no need to discuss once again. Q is point load. R is radial distance. As you know, this is the Westergaard theory. It is also assumes load is point load. And very important, I need to calculate vertical stress at any depth Z at a radial distance R. So I know what I have to do. I need vertical stress at a point P, which is located at a R and Z. Okay, now R is radial distance. Now the thing is Z is vertical depth. So you can see here it is a very bulk equation, but don't worry, I am going to tell you some logic here. Here you see, this is the equation originally given by the Westergaard in order to calculate vertical stress due to applied load. The applied load is point load. Now, actually, how to mention the Westergaard himself is clearly mentioned. The settlement is allowed in vertical direction only. Here you see, the soil is allowed to settle I will write here because I never hesitate to write. I will write the fourth assumption. Soil is allowed to, I will give you a good explanation, stay in line, allowed to settle in vertical direction. In vertical direction. So let me tell you, so we are allowing settlement only in vertical direction, allowing settlement strain in vertical direction. Now someone can ask me, what about strain in horizontal direction? So we, Westergaard himself having made an assumption, the soil is laterally confined. So I can write, in other words, the same assumption. I can write in other words. In other words, soil is laterally confined. Laterally confined. That means soil is not allowed to move. In horizontal direction. So now, what is the value of horizontal strain now? What is the value of horizontal strain? What is the value of horizontal strain? Is going to be 0. Going to be 0. Let me read now the fourth assumption. Soil is allowed to settle in vertical direction. In other words, if you are not happy with my statement, you can have your own statement. Soil is laterally confined. That means what I would like to tell you, soil is not allowed to move in horizontal direction. Horizontal direction, that means it is laterally restrained. It is laterally restrained. Soil is allowed to settle in vertical direction. So when then there is we are neglecting strain in horizontal direction means, so eta H is going to be 0. In that assumption, now I can write Poisson's ratio 0. If Poisson's ratio becomes 0, what is going to happen now? Sigma z is equal to q by 2 pi z square, and it is going to be square root of 1 by 2, and now this will be it will be 1 by 2 plus r by z square whole power 3 by 2. So now it is very easy to understand the entire equation. Now sigma z is equal to q by 2 pi z square. So now this square root 1 by 2 is getting cancelled now, but it will give 2 here. So now 1 by 1 plus 2 into r by z square whole power 3 by 2. So this is the equation actually proposed by Westergaard. So let me tell you now, here you see it is q by 2 pi z square 1 plus 1 by 1 plus 2 into r by z square whole power 3 by 2. So now the thing is,